Okay, given the inequality, we're supposed to solve it and give the solution not in set notation, but in interval notation. So we go about our business and solve it as before, 3x plus 4x distributing minus 4 distributing greater than 3. Combine like terms. That's negative 3x and 4x. That gives me a 1x minus 4 greater than 3. Get the x by itself, plus 4 plus 4. And we got x is greater than 7. So to get the interval notation, I like graphing it on the real line first. So let's go graph this guy. So I'm going to go stand at 7. And then this says x is greater than 7. So I'm going to shade to the right of 7. And since I have no equal sign, just greater than, I'm going to indicate either with an open hole or parentheses. Now, I didn't ask for the graph, it asked for the interval notation. I like doing the graph and then getting the interval notation because for interval notation, you basically give us where you start, comma, where you sort of stop as you walk left to right. So as I'm walking left to right on my real line, I go through, and the first place I hit my solution is at 7. So my starting location is 7, comma, I keep walking, so you basically concern yourself where the shading starts. The shading starts around 7, and then I keep walking forever and ever, and I never really stop, and as I go all the way to the right, I go all the way to positive infinity. And then positive infinity, you can technically never reach it, so we leave it as open parentheses, and we know that 7 had a parentheses with it. So interval notation solution for part A is the solution starts from 7 all the way, keep going to infinity. So where you start, sort of, and where you stop, but in this case you don't stop, you keep going on to infinity. At the right, as you walk to the right, there's plus infinity, and as you walk to the left, there's negative infinity. My solution doesn't include any of this because there's no shading here. The shading starts at 7 and keeps going to infinity. So that is the solution in interval notation versus set notation. They didn't ask, but just a review. Set notation would be x such that this guy gets satisfied. So interval notation has the parentheses and brackets involved. Set notation has the braces involved. Let's do another example. So again, first I got to solve this and then go get the interval notation form of the solution. In order to solve this, since I don't like the fractions, I'm going to multiply each chunk by the LCD, which in this case is 6. Everybody gets a 6, including this one that has a denominator of 1, technically. So once I do that, I end up with 2 for this guy. 6's completely go away here. I'm going to have to multiply 6 and 4, and then 2 and 6 cancel out or divide out and leave me with a 3. So I got 2 times x, 2x. 6's were gone, minus 5, greater or equal to 6 times 4 is 24x, and half of 6 is 3. That's a negative 3. I'm going to want all my x's on the same side. Let's say I subtract 24x from both sides. That's negative 22x minus 5 greater or equal to minus 3. Then I will add 5 to both sides. That's negative 22x greater or equal to 2. Divide by negative 22, divide by negative 22. And since I divided by a negative myself, I have to flip the inequality and make it x is less than or equal to. It looks like I can reduce 2 over negative 22 if I divide top and bottom by 2. So that's going to give me with a 1 over negative 11. So now I got to sort of approximate what this number is in order for me to be able to visualize it on the real line and then get the interval solution. So we're thinking this is sort of saying that x is less than or equal to, if you divide out 11 into 1, so you can punch it into your calculator, 1 divided by 11, and you're going to get 0.090909 forever and ever. So we're just going to think that for our purposes, when I approximate it on the real line, x is less than or equal to, I'm just going to round it, 9 will make that into a 0.1, approximately. So again, I'm sort of approximating because I'm going to show it on the real line. I want to get a sense of it. In my final answer, in interval notation, I will have this exact value. This is actually the actual exact value. This is sort of an approximation, and let's keep in mind it's a negative because it had a negative in the denominator. Okay, so let's go graph this guy on the real line. I'm going to zoom in sort of on the left because I'm dealing with a small negative number, small and absolute value on the left. So I'm going to zoom in and say negative 0.1 is maybe somewhere around here. Like if I were to divide this into 10 pieces, 1/10 would be 0.1. So I'm going to go ahead and say I'm standing around there. That's negative 0.1. And it says x is less than or equal to, so I'm going to have to shade to the left. And since I have that equal sign, this is going to be a bracket for my solution. And again, I didn't have to graph it. I just like graphing it because I like going from the graph to the interval notation. Notation, remember, all the way as you go to the right, it's positive infinity. All the way to the left is negative infinity. And when you do the interval notation, you always sort of start, comma, stop for the answer. And you always walk left to right. So I'm coming all the way from here, walking left to right. It looks as I'm walking left to right, I have the solution right here, and I'm coming all the way from back here, and that's negative infinity. So I'm coming all the way from back here somewhere. That's where all the red stuff is, the solution. From negative infinity, comma, I keep going from the left, from negative infinity I come, because that part, all of that is shaded. Keep going, and then I stop right there. And where did I stop? I stopped at this number right here. I want to put it in exact form. And it includes that as part of the solution, so I enclose it with a bracket. So interval notation says all the way from negative infinity, comma, to negative 1 over 11. Okay, in this problem, it's already given to us. The graph is given to us. All it says is put the solutions, whatever they represent here, in interval notation. So all I got to do is just say, okay, I'm going to worry about where my solution starts and where it stops. So as I'm walking left to right, I have nothing, because there's no shaded region, nothing. First place I have something shaded happens right here, which is at negative 1. So I start at negative 1, and then I have my shaded stuff, solution, and I never stop. I keep going all the way to the right to infinity. So in interval notation, this graph would be from negative 1 to infinity. Okay, let's look at part B. All we got to do is give the interval notation representation. So we're going to walk all the way from left to right. So I'm coming from way down here somewhere. And as I'm coming, I do see that I have shaded regions here, which means where I'm coming from the left, where the solution is contained, I have negative infinity. So negative infinity, that way, all the way to the left, I had shaded stuff. So shaded, and then I stop right there, which looks like it's a 4, comma 4, and then I stop, including 4, close the bracket, and then I don't have anything shaded past that, so my shading sort of quote-unquote started at negative infinity and stopped at 4, and that is the solution in interval notation.